Right triangle trigonometry. Consider a right triangle with theta as one of its acute angles. The trigonometric ratios are defined as follows. So first, in a right triangle, we have the hypotenuse, the opposite side, and the adjacent. The opposite side means the side that is opposite of the angle theta. Okay. So the trigonometric ratio is defined as follows. Sine of theta equal the opposite divided by hypotenuse. Cosine of theta equal adjacent divided by hypotenuse. Tangent of theta equal the opposite divided by the adjacent. And we have the reciprocal function as follows. Okay. In the first example, we want to find the trigonometric ratio of the angle A in the given right triangle. And we shall go ahead and skip C and D. I put it in here by mistake. You need some inverse function before you can solve this problem. We can come back to this later if you would like to do so. Okay. And we will write the answer of the trigonometric ratio in simplified fraction. Okay. So sine of A equal the opposite divided by the hypotenuse. Cosine of A equal adjacent divided by the hypotenuse. Tangent of A equal opposite divided by adjacent. Cosecant of A equal the hypotenuse divided by the opposite. Secant of A equal hypotenuse divided by adjacent. And cotangent of A is equal adjacent divided by opposite. Sine of A in this case equal opposite divided by hypotenuse. We simplify this by 4. Cosine of A equal adjacent divided by the hypotenuse. Excuse me. Inside of A, we have 34 instead of 36. So in that case, we have to simplify it by 2. And we simplify the cosine by 2 as well. Then tangent of A equal opposite divided by adjacent. Cosecant of A is the reciprocal of sine of A. Secant of A is the reciprocal of cosine of A. And cotangent of A is the reciprocal of tangent of 8. Let's talk about the cofunction of complement. Two angles are complement of each other if the sum of the angle equal to 90 degrees. Okay. Let's find the value of sine of 30 degrees and cosine of 60 degrees in a 30, 60, 90 degree triangle. Okay. So we know that in standard earlier we have sine of 30 degrees in a unit circle that is equal to 1/2. And cosine of 60 degrees is also equal 1/2. Note that 30 degrees and 60 degrees are a complementary angle. So sine of 30 degrees equal cosine of 60 degrees Or I can rewrite cosine of 60 degrees as cosine of 90 degrees minus 30 degrees. Here we want to use the calculator to calculate the value of sine of 42 degrees and cosine of 48 degrees in the right triangle, and we want to round the answer to 4 decimal places. So let's take a look here. Sine of 42 degrees equal sine of 42, that is equal to 0.6691. Now remember, if you calculate this and you get something different, you may want to check to see whether your calculator in degree or radian. The way to check this for TA84, click on mode and take a look here. As you can see, the degree is highlighted. So this calculator is in degree mode. Yeah. Now let's take a look at what cosine of 48 degrees look like. It is of the same value. So note that 42 degrees and 48 degrees are complementary of each other. So then sine of 42 degrees equal cosine of 48 degrees, or I can always say that this is cosine of 90 degrees minus 42 degrees. Yeah. So let's summarize this in the cofunction identity. We'll have two columns here. One is for degree and one will be for radian. Sine of theta is equal to cosine of 90 degrees minus theta. Cosine of theta equals sine of 90 degrees minus theta. Tangent of theta is equal to cotangent of 90 degrees minus theta. Now the same for the reciprocal function. Let's take a look at it in the radian. Sine of theta is equal cosine of pi over 2 minus theta. Cosine of theta equals sine of pi over 2 minus theta. Tangent of theta equal cotangent of pi over 2 minus theta. The same goes for the reciprocal function.